Okay, so this is going to be the guided practice for your last week of any new material. This is the very last thing that we're doing in trig, and it's actually the end of the unit. We finished the entire trig unit. Now next year you'll use trig in circles and in volume and in a good bit of stuff. But this is all the basics and all the stuff that you need to know, so you probably want to keep up with the notes that you've taken throughout digital learning over this, because you'll only go over a review for this next year. A couple of things we're going to have to use on this paper is the triangle sum theorem, which just says that all the angles in a triangle equal 180. And then the Pythagorean theorem, which you guys know we've reviewed. And then just to remind you, we've got triangle ABC. This would be angle A and angle C. Angle B is the right angle, so we don't do sine, cosine, and tangent with that. What's going to happen here, and this is the very last standard. There's only 3 standards in this unit. This one just says that sine of A would be the same as cosine of C. And we can switch that around. We can say that cosine of A is going to be the same as sine of C. And basically, it's just whatever a sine is of one angle, it's going to be equal to cosine of the other. And the reason that is because these two angles have to add to 90 degrees. If you remember, angle B is 90 degrees, so we could plug that in right here. And say that that's equal to 180. Now I'm going to subtract the 90 from both sides, and we know that these two angles, 180 minus 90 is going to be 90, are going to add to 90 degrees. Since this is true, we can say A and C are complementary angles, and we can also say that these two things are true, and that's the reason that that is going to be true. So we're going to be using this to shorten out a little bit of work. Instead of saying all the angles add to 180, we can say those other two angles add to 90. So let's go ahead and try some of these. This one is an example. It says that sine of A is 4/5, cosine is 3/5, and we want sine of B, cosine of B. Let's make sure that those fractions are what they're supposed to be. I'm going to start by looking at B, since that's what we're working with. And I'm going to look for that adjacent and opposite. Hypotenuse is across from right angle. Adjacent is in between. Opposite is across. So that's B. Let's pull out our sticky notes. Opposite over hypotenuse is sine. So that would be 3/5. Cosine of B would be adjacent over hypotenuse. So that would be 4/5. And we can check and make sure this rule I showed you fits. Cosine of A was equal to sine of B. They're both 3/5. Sine of A was the same as cosine of B. They're both 4/5. Number 2 doesn't actually require too much work. It looks like it does. But we just know we need to find angle E. And they told us the angle D was 30. So all we're going to have to do is say 90 minus 30 gives us 60. So we've got 60 degrees there. And then we're going to use those rules I was just showing you. We know that sine of E is equal to cosine of D. So this would be the same answer. So I'm just going to write it in the blank. And sine of D is cosine of E. So I'm just going to write that in this blank. And I'm going to keep the number of digits that they have there, so we are keeping our significant digits. That's really useful when we're doing physics or chemistry or anything where you apply math. Going on to number 3, we have sine of J, cosine of K. They didn't give us anything filled in here already, but they did give us 2 sides. And we know the Pythagorean theorem, so we know how to find the third side. We could do tangent here, but we can't fill in any others. So we're going to have to use the Pythagorean theorem. So I'm going to say 10 squared plus 24 squared is equal to h squared, since that's the hypotenuse. And I'm going to go ahead and square those. Combine them. And take the square root of both sides. And we get h is equal to 26. Now all we have to do is do one of them, since we know the opposites are going to be the same thing. So I'm going to fill in sine of j first. So let's do j. So adjacent is in between. Opposite is across. And we can fill these in. Opposite over hypotenuse is 10 over 26. Adjacent over hypotenuse is 24 over 26. Now I do have to reduce those. These are both divisible by 2, so we're going to reduce that to 5 over 13, and this one to 12 over 13. Now I don't need to do any more work because I know that cosine of j is the same as sine of the opposite angle, which is k. Same thing here. Sine of j is the same as cosine of k. So we've got our answers. Notice that I haven't used tangent at all. This rule doesn't work for tangent because it doesn't involve the hypotenuse. Okay, so I've gone ahead and subtracted here to figure out what this angle is worth. We just know that those two add 90.